Let us learn about magnetic fields. Magnetic fields have both magnitude and direction. However, we cannot calculate the magnitude of the magnetic fields right now, but we can surely observe the direction of magnetic field. To observe the direction of magnetic field, we can do it with the help of a compass needle. There is a magnet which is placed on a whiteboard, and if I align the compass needle, what do I observe? That the south pole of the compass needle coincides with one of the poles of the magnet. This pole will be termed as the north pole of the magnet. Now, if I observe the magnetic field direction with the help of the compass needle, I see that here I make it a point. Again, here we see that the south of the magnetic compass is coinciding with the magnet. Gradually, we are making the points moving in this direction, and by doing so, we observe that you observe a pattern over here as it is marked. What do we observe in this pattern? They emerge from output and moving towards the north. Yes, we observe that the magnetic field lines are emerging from the north pole and they are merging towards the south pole. When they travel inside the magnet, they are moving from the south pole to the north pole. Therefore, the direction of magnetic fields outside the magnet will be from the north pole to the south pole, whereas inside the magnet it will be from the south pole to the north pole. This concludes the direction of magnetic fields. When we observe the pattern which is over here, we observe that it forms a closed loop. To observe this pattern more significantly, we will be using some iron fillings. If I randomly sprinkle these iron fillings over this arrangement, and if I tap it, we observe, and even if I disturb it again and then tap it, we see that they align in closed loops. The loops are very visible here. Okay. Therefore, the magnetic field lines are closed curves. The relative strength of the magnetic field is shown by the degree of closeness of the magnetic field lines. If we again focus here, we see the magnetic field lines in this region are very close to each other. Therefore, they are very strong magnetic fields. Whereas, when the magnetic field lines move away from the magnet, the distance between them increases. Therefore, the relative strength of the magnetic field decreases. Another factor which we observe is that no two fields, if you look over here, this part, no two magnetic lines are crossing each other. Therefore, none of the magnetic fields, they cross each other, they form concentric closed loops. The closed loops towards the inner side are stronger, and the strength of the closed loops as you move away from the magnet is relatively lesser.